All right, apparently we are live now. Hopefully the audio is sounding a bit better than last time. So we're going to continue on with our, assuming the audio is correct, we're going to continue with our NFC device, which is going to read NFC tags and allow us to be able to lock out equipment or provide like a door access or something from something like a ST dev kit and the Room 32 module. So previously we were doing the ESP32 hookup. I have my notes, so hopefully we can build something. Yeah, the audio might get, I don't know, because I've got the audio routed a weird way, but as long as the audio is audible, I'm happy at this point. Says last time the audio is not very good. And again, this is it is the hottest day of the week and one of the hottest days of the year. And I've got no fans on, so it's going to be warm in here. So I'm going to try and keep this to about an hour because it's just too hot. All right, where did we get to last week? I know we have to do the display. We've got our NFC reader done. We've got our antenna matching done. That was the last thing we did last week. And we have our ESP32 started. Still need to get a lot more hooked up. Okay, so I think we're done with this one. So how about we start on the e-paper display? So I was looking at using this e-paper display so that we can have it running very low power. And I've wanted to play with e-paper for a while, so I figured it's a good way to give it a shot. It's also quite cheap. It's going to be one of the cheaper options for a display of this size and resolution, no matter what. So if we can also get e-paper out of it, then that seems pretty good to me. So add a new schematic for this one. And my templates seem to have updated because somehow I have Altium's address in here. And I haven't touched Altium since we last used it. So that's kind of interesting. Well, I haven't touched Altium Design at least. Oh well. We now have Altium details loaded in here. And the funny thing is that I don't know if that's still their address, because I know that the headquarters is in California now. So yeah, I don't know if that's like still their Australian stock exchange listing perhaps is still there. Oh, I know what I think I did. I did change preferences here. Under schematic. Yeah, I changed the default template to A4. So maybe that template file has Altium's address in it. That would make sense. And I'm still getting used to this keyboard. So there's always that. Hello, people. Hello, Arabic people. I think that's Arabic. So we are looking for a connector. I already have two options preloaded in here, but that one's not in stock, so we won't go with that. So the option which the e-paper display datasheet recommends is generally hard to find in stock, and it's also quite expensive, where this is $1.46. I think it's about $3.50. So this is the same FFC thickness. It's the same pin pitch. It's over under, so you can have your contacts on both the top and bottom. So it should be 100% compatible. but I guess we'll find out if we make this board. Right, so I have my pinout listed down here. So because I'm just using a generic connector, I'm going to place, not print, I'm going to place, if I can hit the right keys, it would help. I'm going to place some text on here, and I'm going to just annotate down here what these are. And if we go to a half grid, so in the bottom left corner here, we've got the grid size. So if you go to a 50mm grid, you can put things off grid, which I normally hate doing, but it works quite well for doing text. And then down to 8. I really find just using the keyboard for this sort of thing is super helpful, because if you're going back and forth between the mouse and the keyboard, you get a sore arm, and it's not very efficient. So using the arrow keys on the keyboard allows you to bump these up and down, which is what I normally do if I'm doing pins for a schematic or something as well. We've got a few non-connected pins on here as well, so I'm just going to leave those and not mark them at all. And that's my last one, so I think I managed to double that up, yep. And of course we've got a ground. This isn't actually a shield. I think this is, I've just got the mount pins here, and I changed my grid back to 100mm. So yeah, we've got, I believe I actually broke a shield pin out, but it's actually just the mechanical connection for the connector, so that it doesn't get ripped off the board, basically. And I'm also going to place some no ERC directives on these pins. I shouldn't get ERC because these are just set as I/O pins in the schematic, but it does make it so I'm not going to connect anything to those. Just if I'm having trouble lining these up because I'm going cross-eyed because it's hot. Okay, so we want to have ourselves a MOSFET. N-channel MOSFET. 702 should be fine. That one's got 2 more million in stock, so we'll go with that. This is a bit of an interesting setup. What am I doing? I'm going for resistors. And we gotta wait for Altium to build up the cache. This is the largest table in the database, so it takes a little while. So this actually might be a current sense resistor. It's a very low ohm resistor, so I might actually have a quick look in current sense for this. I'll just check the data sheet as well. So while I have my schematic here, I just want to check my pin assignments. Yep, current sense input for the control loop. That's what I thought. So we're looking for a 47 milliohm resistor. What sizes do we have in here? Yeah, that MOSFET is so common and so cheap, and the SOT23 package is kind of big. Something like the SC70 might be nicer for a board like this, but it's fine. And hello, Leonardo. What are we looking for? We're looking for a package case, that one. So this category has everything in it. So I want to just quickly look for an 0603, I think. Try and keep this all 0603. I mean, I don't have a problem with doing 0402s at all by hand, but if we're making this open source, it's always nice to go with a slightly larger one, especially if there's no demand for a smaller footprint. These are not cheap. All very well stocked. Okay, we'll go with that one. That one is the cheapest. So I'm sure we're going to need to do a bit of rearranging as we go here, but we'll just get the connections in for now. We need to steal some capacitors from somewhere. As I said last week, it's just easier if you can copy and paste parts from other schematic sheets and you don't have to try and find the right one in your library. It saves a little bit of time. Saves a little bit of bomb count if you accidentally put two of the same value in there. Okay, so we're looking for a ferrite. So when I'm looking for a ferrite, as I've said in chat before, I'm generally trying to maximize impedance at frequency, minimize DC resistance. Just want to double check that this is actually a ferrite. This might actually be a boost circuit. It's not a ferrite. My mistake. Lucky I checked that. I thought that looks, with the current sensor and a MOSFET there, that might actually be a bit of a boost supply. And I think that is. So we're actually going for an inductor. My bad. Always good to check the datasheet. This is why, even if I do have notes printed out and I've got schematic from the datasheet printed out, it's always a really good idea to just double check everything you're doing as you go through the schematic, because I thought, oh, that's going to be a ferrite, but it's not. And it's very easy to make that mistake. they had a 0.8 amp current rating on their inductor. In the data sheet, I'm assuming we could get away with a little multi-layer ceramic, but let's see if we can find a relatively cheap thing like one of these perhaps. But yeah, these are nice. These are the TDK VLCF 4024s. I really like these. They're a good looking package, really easy to solder as well. All right. So then they've got, this is feeding down to, yeah, here. So this is giving us our boost voltage to VGH, and then, so it's basically giving us our high and low voltages out of this. Just look this up on DigiKey. We can, pretty sure this is a Schottky. Of course it's not. And it's not a standard enough part number that we're going to find, I don't think. Oh, okay, we should have those. Yeah. We should be able to do exactly the same part number they had with this ON semi part. And 3 of these. Excuse me. Right, we need a, I don't think we had a 4.7 microfarad cap in here before. Just do a quick scan through, and if we add a new one, there we go. Okay, I don't have one. So yeah, speaking of frustrating things of Altium having to select all these columns again every time you change category, we're making pretty good progress on the extension at the moment. So we can now get a full list of parts, and just about at the point we can place any part from the database without using the component panel. So we've proven that just in a quick sense before. So we just did a really dirty prototype which didn't actually take any data from our services. But we can now take data from our web services, and just about the point we're able to drop those parts onto the schematic rather than just having dummy values in there and a preloaded symbol and footprint, which is kind of awesome. That's what I'm looking for. Really looking forward to having this extension at least in a prototype stage so we can start using it, because it's going to allow us to do some really cool stuff with Altium. I'm hoping eventually we can get to the point of, in the search window, you can say, I want to place this, or I want to place the whole schematic related to this. So if we're like placing an ESP32 like this, we can place it down and have all the decoupling caps and everything already in place, which would be amazing, but that is a bit of a ways off. Just need to get it actually placing parts first. Man, these caps are not very well stocked, are they? All right, we've got one now though. This connector actually has a ton of decoupling caps on it. It's asking, you mean placing schematic parts like placing component parts? Pretty much. So it'd be like a composite component, or initially it would be sort of like a templated schematic item. I know Altium can do something like that, but not from a library. So we want to be able to make that happen from the library itself, which I think would be pretty amazing, especially if you're always using microcontrollers and stuff. You can just drop one in and have it all set up ready to go. Or especially power supply. So you might be able to choose from a power supply and just drop in a switch mode regulator, which is all calculated out for, say, 5 volts, which would be, I think, pretty handy to have. Because I've got schematics for pretty much most of the ICs in the library because I've used them. So, you know, I might not have the exact implementation you want, but I would have something pretty close to it, I imagine. There's a lot of decoupling in this thing. You mean the jumper here? That is in preferences. Where is that? It's under tools preferences. That's the one. So we go to graphical editing, I think it is. Oh no, it's here, the display crossovers under options. So you go preferences, tools preferences, schematic, general, display, crossovers. I like having it on because it makes it very clear, like here, this is balked. Just provides extra visibility because, yeah, it's great to have the little junction dot, but that's not always enough to really show that it jumps over. It's a pretty old school sort of style, but I like it. I'm just going to put these net labels down and we'll break this out to a harness later on. No, that's meant to be CSB. Whoops. Oh, it's like 35 degrees in here. I know that's not that hot for some people, and definitely a cool summer's day for where I grew up, but it's not what I'm used to. All right, so we've got lots of complaints there about that only having having a single pin, but that's fine. All right, I think I've got all those decoupling in now, so we can go back to building our little booster circuit here. This is going to get a little bit messy, I think. Just going to break this all apart and try and lay it out a bit better. We've got plenty of room here. I just want to make sure it's going to be nice and legible in the future. go. That looks pretty terrible. Bits going everywhere. I really don't like it when you've got to follow nets all over the place, but I think it looks messy. It makes it hard to follow, but I'm not sure if I've got a better way to do this right now. I can always revisit this. If I just check I've got everything, which we had in our reference schematic. 4 caps there, yep. Okay, I think that should be our display hooked up. I just need to put a harness in for this. I'd love it if Altium were to put a way to just clear all of these at once. I haven't figured out, I mean, you can kind of select all, but it'd be nice if there was just a button to just delete everything. Be a lot more convenient. And again, if this would work with the keyboards, I'd have to keep going back and forth, so the mouse would help a lot as well. Should probably put in a request on the forum for that, because otherwise it will never get added if nobody requests it. We need a harness connector. So this will show up on our top sheet when we get to that point. Ari is saying smart paste your labels. I'm not sure what you mean by that. Can you explain? I might be able to learn something here. That'd be great. I'm actually working on a tips and tricks article for the Altium blog. So if you've got a better way to do the labels like that, I'd love to hear it. If you've got time to explain. Do you mean in the grid here we can smart paste into here? I know there's a lot of lag for YouTube, so hopefully, this is about 30 seconds behind, I think, for me. So hopefully, well, maybe more like a minute behind even, despite having the low latency section. So, well, hopefully Ari comes back to us with an awesome tip. I will continue on. So while we're working on human-machine interface side of things, I'm going to add a buzzer and a connector for our SSD. So because the microcontroller, well, so the NFC controller, which we get in our little dev kit here, does not have a way to provide an audible notification that something is happening, I'm going to add a buzzer. So if they scan their little NFC tag against the scanner, it's going to go boop, and we'll also be able to then have an audible notification that perhaps it's about to time out and switch the machine off, or something else, depending on what people are going to use it for. So let's have a look through what we've got here. We are powering this device by 5 volts, so a 5 volt rated one would be fine. Look at single tone, single tone, single tone. Actually, these are all single tone devices. So they should just need to be switched on and they'll generate a noise themselves. Don't think we got to putting speakers in here. I'd like a piezo speaker so I could do different tones, but for now I think we'll do this, and I can always change this later on. So that's 76 dB, 88 dB, 92 dB. Now we're talking 92 dB. Yeah, let's go with that. Except 3.6 volts. Let's go with a 88 dB one, because that was a 5 volts, and I have to go and add another voltage regulator to this. Work out cheaper overall. Current-wise, it's not going to use much, so I can use the little MOSFET from here. Help if I click the button properly. So I can copy the, if I was to copy these, I can potentially Shift Control V and select harness connector. Okay, so can I smart paste as harness connector and port? Let's give that a go, see what happens. Port name. Oh, that is cool. Okay, I definitely have to remember that one. Thank you very much, Ari. I like that. Yeah, we're gonna have to remember that one. That one's going on my my tips and tricks list for sure. I like that a lot. That's great. Thank you. Why is that showing up like a harness? Oh, I unselected that. Whoops. Okay, there we go. And so we don't blow up our 5 volt supply from a piezo device, we should probably put a diode on there. And we have to have just put a whole bunch of diodes into this circuit, so let's just grab one of these. And a little one of them as well. So now I'm going to add the opto isolator and a connector. Just going to use a terminal block so that we can have a external SSR solid state relay to run power through the device, so like a machinery or something. I'm not going to bother with putting a solid state relay on board because we don't know what the current demands are going to be. We don't know if it's potentially going to be like a 3-phase device where this would control a contactor instead of a solid state relay. So we want to make sure that we're not restricting what people can use this for, and we want to also make sure that we're going to not have any AC on this board, because that ends up with all sorts of regulatory stuff I just don't want to get into. Now we've got different options here. What are the sizes of these? Pin pitch 3.5, 3.81. We'll go with the Molex. This is Molex, isn't it? Yeah. These are fairly new in the library. Solid state relays will take pretty much any voltage, but I'm going to give it 5 rather than our regulator, just in case someone hooks a relay or something up to it. We want to make sure that it's going to have a good amount of current available rather than stressing our regulator. And that way, if something goes wrong, we can blame them rather than us, which is always good. As far as them not having a powerful enough 5-volt supply, that is. So because it could have a relay hooked up to it, again, some protection there, make sure that we snub anything out. And that's also a external connector, so people might touchy it, and that can lead to excitement we don't want to deal with, so let's put a TVS diode in there as well. So what I want to do here is I want a bidirectional one. So if I group by bidirectional channels, I'll have unspecified or 1. Which will give me the ones I want. And then we're going to sort by our breakdown voltage, because we want this to be at least the voltage we're going to expect on it. Reverse standoff's not quite where I want it to be on those. 6-volt reverse standoff, that should be fine. Although some chargers do put out a bit of voltage, don't they? So maybe we should go like 7-volt. Yeah, that might be better. Because our voltage regulator will handle the higher voltage pulse, but it won't handle the ESD shock. So where's our price column? We are sorting by price, yes. Not enough of those in stock. That one looks pretty good. So I'll throw a TVS diode in there too. I don't think we need too much more of the schematic done. So we're almost at an hour and I am feeling quite warm. There's only 27 of those in stock. Probably not the best choice for a design. Oh dear. What are these rated for? Voltages are all good. And current's not brilliant. More than enough what we need though. Oh, we should put a resistor in there, shouldn't we? So we have that all in the schematic. What do we want to do for resistor? Something. Probably want something around 330 ohms. I could calculate it out, but for a 1.2 volt forward voltage, this should provide us with enough current restriction. It's not the current restriction for the opto isolator I'm worried about. It's more for the microcontroller, because I don't know what the ESP32 pins are going to be rated for, but most ARMs will only handle about 6 to 7 milliamps on their pins. So we want to, that's my primary thought for a restriction, is going to be making sure that the microcontroller can supply enough, well, won't supply too much current rather, and burn out. It's never the LED, it's always the microcontroller. It's limiting, unless you're using a pretty old microcontroller. Line that up, that'll be fine. Okay, so that should be our opto. And that's also our buzzer done. So we're getting there. So we've got the display, we've got the buzzer, we've got the solid state relay controller built in. We've got, still need to do, what do we still need to do? We need to do a reset button, a boot loading button on the microcontroller side of things. We're going to need to put in a USB UART as well. Yes, and yes, it should actually. Alex is correct there. I was thinking about just the input there. So let's break that out. Oh, no, that's not what I want. What am I doing? There, that's better. Otherwise, that would be always on. And that's not what we want. Okay, that's a bit better. Great suggestion there from Alex. Right, I know we haven't got too far on this, but we've got an amazing suggestion from Ari. Because it's quite hot, I'm going to say we're going to call this at an hour. Last time we went a lot longer, but oh man, it is warm in here, really warm. So what I'm going to do is say we'll call it there. I am sweating like crazy, which you guys probably don't want to hear, but perhaps on Monday. I've got this all set up now. I've got two 50-watt light panels up there, so I can actually light my bench, and we're going to get the teleprompter off that camera because it's too big, and we'll get in there and we'll do a behind the scenes filming of doing some board assembly, as I said last week. So I'm hoping Monday night we'll be able to do that, and I've got everything set for that now. Last week I was waiting on making this little thing, so I wanted a tray which I could sit my stencil on. I now have laser cut and engraved a little tray, so this is just going to make it so I can put the stencil and board on here and lay it out, and then be able to take this away, which is going to make filming easier. So if you want to come along and maybe ask some questions about surface mount board assembly, then we can have a little chat there, and that will allow me to create potentially a better tutorial video, because I'll have some great suggestions and tips and tricks and just questions about what I'm doing, how I'm doing it, which we can edit into the real video. So that would be great. I'm going to try and do a relatively short, rapid tutorial for doing a board at home on the cheap. So the most expensive part is going to be the solder paste. It's going to be a double-sided board, so we're doing front and back, which is going to get really interesting with that stencil setup. Might need to laser cut another template for that. Yeah, I'm just going to hot air it. So stencil from the PCB manufacturer, they're like 12 bucks. So they cost nothing. And we're going to assemble a board, but it's going to be a much longer process in the live stream, because I'm going to have all the cameras and such to be moving around and lighting and such. So I imagine that a 5-minute video will probably take about an hour and a half to 2 hours to actually film. And we're going to try and see if we've got enough light to crank the Ursa up to 150 frames per second at 4K to watch some solder melt. That'll be interesting when we get to the actual final video. But thank you very much for joining me. I hope you've had a fantastic day. Thank you again for Ari for that amazing suggestion of the smart paste. I did not know you could smart paste a harness, so that is just awesome. I really appreciate that. And thanks for Alex for pointing out that I did something kind of dumb there. But I hope you all have a fantastic day. And if you're not on Discord, I've got like 140 people watching now. Wow. Then feel free to join us on Discord, and the link's in the description. It's a great place to hang out and chat and join the community.